Before we proceed to integration, first, let us have a throwback. What is this basic differentiation rule? The derivative of a constant is equal to 0. Very good. This is the constant rule. How about this one? What is this basic differentiation rule? The derivative of u to the n is equal to n times u to the n minus 1 du. Correct. This is called the power rule. How about this basic differentiation rule? The derivative of ub is equal to udv plus bdu. Very good. This is called the product rule. Lastly, what is this basic differentiation rule? The derivative of u over b is equal to b du minus u dv all over b squared. Correct. This is called the quotient rule. This is familiar to you, right? The IPO process, input, process, output. This is commonly used in research. In mathematics, we have the given, the solution, and the answer. Let us relate this with calculus. In differential calculus, the given is the function, the process or the solution is called differentiation, and the answer is the derivative. While in integral calculus, the given is the derivative, the process or the solution is called antidifferentiation, and the answer is the function. Antidifferentiation is also called integration. Example on differentiation. Let's get the derivative of 5x squared plus 7. The derivative of 5x squared is 10x dx. The derivative of 7 is 0. So the derivative of 5x squared plus 7 is 10x dx. Now let's have an example of integration. Let's say, let us get the derivative of 10x dx. This is a symbol for integration. The integral of 10x dx is 5x squared plus c. Why plus c? Because there could be any constant or any value of the constant. That's why we will just write c. C is called the constant of integration. Here, the integral of 10x dx is equal to 5x squared plus c. This is the integration symbol. 10x is the derivative or the integrand. Dx is the differential of x. 5x squared is the partial integral. While 5x squared plus c is called the indefinite integral. Now let's proceed to the basic principles of integration. The integral of a dx is equal to ax plus c. The integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. Examples. Number 1. Let us integrate negative 3 dx. The integral of negative 3 dx is equal to negative 3x plus c. Number 2. the integral of 12x squared dx. It will become 12x squared plus 1, or 12x raised to 2 plus 1 over 2 plus 1 plus c. 2 plus 1 is equal to 3. That's why it will become 12x cubed over 3 plus c. Do not forget the constant of integration. 12x cubed over 3, we can simplify this one. This can be expressed as 4x cubed plus c. So do not forget to box your final answer. Exercises. Now, integrate negative 24x to the fifth dx. And number 2, integrate negative 9x squared plus 10x dx. Solution. Number 1, the integral of negative 24x to the fifth dx. I'll be giving you 30 seconds to solve this. You may pause this video for you to have more time in solving this example. Okay, let's check if you did the same process. This will be equal to negative 24x to the p plus 1 over 5 plus 1 plus c. This will become negative 24x to the 6 over 6 plus c. This will become negative 4x to the 6 plus c. This is the answer. Did you get the same answer? Very good. Next. Integrate negative 9x squared plus 10x dx. Again, I'm giving you 30 seconds to solve this. Let us see if you get the correct answer, or if you did the same process. This will be equal to negative 9x squared plus 1, or negative 9x to the 2 plus 1 over 2 plus 1 plus 10x to the 1 plus 1 over 1 plus 1 plus c. This will become negative 9x cubed over 3. And this will become 10x squared over 2. So we can actually simplify this. This will become negative 3x cubed plus 5x squared. Again, do not forget the constant of integration. So this is our final answer. Did you get the same answer? Very good. Let us have more exercises. In this case, we have negative exponents, and we have variables with exponent in the denominator. Okay, first, solve for this. The integral of negative 4x to the negative 3 plus 20x to the negative 5 dx. I'm giving you 30 seconds to solve this one. You may pause the video if you need more time. Okay, let's see if we do the same thing. This will be equal to negative 4x to the negative 3 plus 1 over negative 3 plus 1 plus 20x to the negative 5 plus 1 over negative 5 plus 1 plus c. This will be equal to negative 4x to the negative 2 over negative 2 plus, we can actually simplify this. This will become negative or positive 20x to the negative 4 over negative 4 plus c. This will become 2x to the negative 2 minus 5x to the negative 4 plus c. This will be our answer. Did you get the same answer? Very good. We can actually express our answer in a different way, since we have negative exponents here. This can be expressed as 2 over x squared minus 5 over x to the 4th plus c. If your answer is this, it is also correct. Next, number 4. Integrate 15 over x to the 4 plus 8 over x to the 5th dx. Okay, let us check your answer. You can actually express this as 15x to the negative 4 plus 8x to the negative 5 dx. Then, this could become 15x to the negative 4 plus 1 over negative 4 plus 1 plus 8x to the negative 5 plus 1 over negative 5 plus 1 plus c. Then, this can be 15x to the negative 3 over negative 3 plus 8x to the negative 4 over negative 4 plus c. This will become negative 5x to the negative 3 minus 2x to the negative 4 plus c. This could be your final answer. Did you get the correct answer? Very good. Just like from the previous item, this can be expressed in a different way. This can be expressed as negative 5 over x cubed minus 2 over x to the 4th plus c. If your answer is expressed like this one, it is also correct. Now let us solve number 5. Integrate 7x raised to 5 over 2 dx. In this case, we have an exponent which is a fraction. I'm giving you 30 seconds to solve this one. Okay, then let's check if you get the correct answer. So this will become 7x to the 5 over 2 plus 1 over 5 over 2 plus 1 plus c. Five over 2 plus 1 is 7 over 2. So this will become 7x to the 7 over 2 over 7 over 2 plus c. So the reciprocal of 7 over 2 is 2 over 7. So let us multiply it to 7x raised to 7 over 2. So that will become, because 7 will be cancelled, this will become 14x to the 7 over 2 plus c. Okay, number 6. Integrate negative 5 cube root of x squared over 3 dx. I'm giving you a clue to help you. You can express this as 5 or negative 5 over 3 x raised to 2/3. This is in the form of radical form expressed into rational exponent. I'm giving you 30 seconds to answer this. Okay, let's see if you get the correct answer. So this will become negative 5 over 3 times x raised to 2/3 plus 1 over 2/3 plus 1 plus c. 2/3 plus 1 is equal to 5 over 3. So this will become negative 5 over 3 times x to the 5 over 3 over 5 over 3 plus c. Then the reciprocal of 5 over 3 is 3/5. That will be multiplied to negative 5 over 3. This will become negative 5 over 3 times 3/5 x raised to 5 over 3 plus c. So in this case, 3 and 5 will be cancelled. So that will become negative x raised to 5 over 3 plus c. So you may express this answer into radical form. This can be expressed as negative cube root of x to the 5th plus c. If you get either of these, then your answer is correct. Now, look at this figure. How do we find the area between a curve and the x-axis from x equals a to x equals b? How are we going to solve or to get the area of this shaded region? Actually, integral calculus can be applied to answer this question. That is the concept of the definite integral. So we are going to integrate f of x from a to b. This will be equal to the integral of f of b minus the integral of f of a. A and b are called the limits of integration. B is called the upper limit while a is called the lower limit. Example, the integral of 10x dx from 1 to 2. The integral of 10x dx is 5x squared. So let us write the limits here from 1 to 2. Then what are we going to do is we're going to substitute the upper and the lower limits. So in this case, we substitute the upper limit first. 5x squared. So that will become 5, 2 squared, minus 5x squared, substituting the lower limit, which is 1. So this will become minus 5 times 1 squared. 2 squared is 4 times 5, 20. 1 squared is 1 times 5. So 5. So 20 minus 5 is 15. Can you follow? Very good. Next. So let us integrate 12x squared dx from negative 1 to 3. So the integral of 12x squared dx is 4x cubed. The limits are negative 1 and 3. So this will become 4 times 3 cubed minus 4 times negative 1 cubed. So the answer here will be 112. Okay, try this one. The integral of 24x cubed minus 9x squared dx from 0 to 2. I'm giving you 1 minute to answer this example. If you need more time, you may pause the video. Okay, let's see if you get the correct answer. Here's the solution. So the first thing to do is to get the integral of this function. The integral of 24x cubed minus 9x squared is 24x to the 4 over 4 minus 9x cubed over 3. We can actually simplify this. This will become 6x to the 4 minus 3x cubed. So let us write here the upper and lower limits. So now let us substitute the upper and lower limits. First, let us substitute the upper limit. So let us substitute 2, then minus, substituting the lower limit to x. So in this case, so you can see here, it is enclosed in a grouping symbol because 6x to the 4th minus 3x cubed is a binomial. So we are going to write minus here, then a grouping symbol. Meaning to say, this entire 6x to the 4th minus 3x cubed, the minuend is the minuend. So this will become 6 times 2 to the 4 minus 3 times 2 cubed minus 6 times 0 raised to 4 minus 3 times 0 raised to 3. So this will become 6 times 16 minus 3 times 8 minus 6 times 0 minus 3 times 0. So obviously, this will become 96 minus 24 minus 0 minus 0. So this will be 0. So 96 minus 24 is 72. Earlier, I've said that the definite integral can be solved to get the area of a certain region. So let's say there is a line that assigns some points here. Let's say this one and this point, because this line passes through those points. Then this is the bounded region. So how are we going to solve for this, for the area of this bounded region? So as you can see, it is a right triangle. So remember that formula for area, or to solve for area of a triangle, is 1/2 pH. In this case, let us count to determine the length of the base. 1, 2, 3, 4. So the base is 4 units. How about the height? 1, 2, 3. The height is 3 units. So if you will be solving for the area of this triangle, A is equal to 1/2 times 4 times 3, which is equal to 6. So the area of this right triangle is 6 square units. Now, the coordinate of this point is 1, 0. And the coordinate of this point is 5, 3. Remember the slope formula? M is equal to y sub 2 over y sub 1 all over x sub 2 minus x sub 1. So let us solve for the slope. This will become m equals 3 minus 0 over 5 minus 1. M equals 3 over 4. So the slope of this line is 3/4. So here, we have a coordinate of a point and the slope of this line, which is 3/4. Now let us get the equation of this line using this point and this slope. What formula are we going to use? Very good. The point slope form, or the point slope formula. Remember, x sub 1 minus x times m equals y sub 1 minus y. So let us substitute the value of x sub 1 and y sub 1 and the slope. This will become 1 minus x times 3 over 4 equals 0 minus y. This will become 1 minus x times 3 over 4 equals negative y. Let us continue here. So actually, by cross multiplication, let us multiply 3 to 1 and to negative x. So that will become 3 minus 3x. And let us multiply 4 to negative y. So that will become negative 4y. Then let us just continue manipulating this equation. This will become 4y equals 3x minus 3. Divide both sides by 4. This will become y equals 3 over 4x minus 3/4. So this is the equation of our line in slope-intercept form. Y equals 3 over 4x minus 3/4. So our limit is 1, then 2, 3, 4, 5. So 1 is our lower limit and 5 is our upper limit. So let us apply the concept of definite integral here. So our function is 3 over 4x minus 3/4 here. So our lower limit is 1, our upper limit is 5. The first thing to do is to get the integral of this 3/4 x minus 3/4. So the integral is 3 over 8 x squared minus 3/4 x from 1 to 5. Let's continue solving this. So let us substitute the upper and the lower limits. So this will become 3 over 8 times 5 squared minus 3 over 4 times 5 minus 3 over 8 times 1 squared minus 3 over 4 times 1. 5 squared is 25 times 3, 75. So this will become 75 over 8. 5 times 3 is 15. So this will become negative 15 over 4. 1 squared is 1 times 3 is 3. So this will become 3 over 8. 1 times 3/4 is 3/4. So 75 over 8 minus 15 over 4 is 45 over 8. 3 over 8 minus 3/4 is negative 3 over 8. So we're going to distribute the minus or the negative sign, so that will be positive. So this will become 45 over 8 plus 3 over 8. 45 plus 3, so these are similar fractions. So we just copy the denominator, so this will become 48 over 8 or 6. So we can say that the area of the shaded region is 6 square units. So this is just a simple example that shows that the concept of definite integral can be applied to get the area. Before we end our class, let me ask you these questions. First, what is the difference between differentiation and integration? Next question, what is the difference between definite and indefinite integrals? So now, let us have a short quiz. Evaluate each indefinite integral. Number 1, integrate 10x plus 4x to the negative 5 minus 2x to the negative 3 dx. Number 2, integrate negative 4 over x squared minus 8 over x to the 5th dx. For number 3 and 4, evaluate each definite integral. Number 3, integrate negative 6x dx, or from negative 4 to negative 1. Number 4, integrate 4x to the 5th minus 2x cubed dx from 0 to 3. For your assignment, have an advanced reading on the general formulas and simple techniques of integration. Let me share you this quotation. Boundaries represent awareness, knowing what the limits are, and then respecting those limits.